Question number 11. So question number 11 wants us to add and subtract radical expressions or add and subtract square roots. Okay. So when we're doing this question, we're going to do it similar to how we did question 10. But in this case, we're adding and subtracting, not multiplying and dividing. All right. So this one is going to be a little bit more tricky. So make sure you follow all of my different steps. Okay. So we need to try to subtract square root of 6 or radical 6 by 8 square root 150. So whenever you're doing these questions, guys, one of your two terms cannot be simplified anymore. So which one of your two terms do you think cannot be simplified anymore? The one underlined in blue, all right? So again, the one underlined in blue, square root 6, all right, cannot be simplified anymore because if I use prime factorization, all right, I can divide 6 by 3, okay? I'm left with 2, but I have no pairs, okay? So because I have no pairs that I can put together, that means this cannot be simplified anymore, all right? The one that cannot be simplified anymore, you're going to bring all the way down, all right? We're going to use it, but we're going to use it towards the end, all right? Normally, there's a number in front of this square root. Whenever you don't see a number, guys, always assume that there's a 1 right here as a coefficient in front, okay? So now let's look at the one that I underlined in red. Do you think I can simplify that? Yes, I can, all right? But I'm only simplifying the number that's underneath the square root, okay? The number that's in front, the negative 8, I'm going to bring it a little bit down, all right? Because I'm not simplifying that negative 8 as yet, okay? So let's simplify the 150 using prime factorization, all right? So let's list out the first 5 prime numbers, which is 2, 3, 5, 7, and 11, all right? Can I divide 150 by 11? No. 7? No. 5? Yes. All right. So I can divide it by 5. 150 divided by 5 is 30. Okay. So can I divide 30 by 11? No. 7? No. 5? Yes. All right. 30 divided by 5 is 6. Okay. So can I divide 6 by 5? No. 3? Yes. All right. And 6 divided by 3 is 2. And I cannot simplify anymore. Okay. So my pairs, I'm going to circle. Okay. Because that's the number that's going to be on the outside of my radical. So I should have drawn my line a little bit lower. All right. But it's okay. So again, the 5 is going to be on the outside of this radical. That's being multiplied by that negative 8. That's also on the outside. Okay, I have a single 3 and a single 2, so that means underneath my square root, underneath my radical, I'll have a single 3 and a single 2 that's being multiplied by each other. Okay, so when I multiply the numbers on the outside, negative 8 times negative 5 is negative 40. When I multiply the numbers underneath my radical, so underneath my square root, 3 times 2 is 6, okay? And now I will bring it all the way down, okay? Now I'm going to try to combine like terms. I can only combine them because both of them have a square root 6 attached. If they both did not have a square root 6, I could not subtract them together, okay? So when I'm subtracting, I'm only subtracting the numbers in front. Okay, so 1 minus 40 is negative 39 rad 6s or negative 39 square root 6. All right, you only write the square root of 6 once. Okay, so again, you only write it once. Okay, and that is it. So let's try the next one, guys. So again, when we look at this example, one of these terms cannot be simplified anymore. Which one do you think cannot be simplified anymore? The one that I underlined in red, all right? So the square root of 3 cannot be simplified anymore, right? Because again, if I use prime factorization, right, I can only divide it by 3, but if I divide it by 3, I'm left with 1, and I have no pairs, okay? So again, this negative square root of 3, I cannot simplify it anymore, so I bring it all the way down, all right? So I bring including the sign, okay? And what can I assume is in front of this square root of 3? A negative 1. Good job, guys, all right? So now let's try to simplify this square root of 12, and also in front of that is also a negative 1. So I'm going to bring that down a little bit, okay? Because again, that negative 1, I'm not going to do anything with it as yet, okay? I need to simplify underneath the square root first, okay? So I'm going to use prime factorization for, so the first terms or the first 5 prime numbers are listed right here. Can I divide 12 by 11? No. 7? No. 5? No. 3? Yes. So I can divide it by 3. 12 divided by 3 is 4. So can I divide 4 by 3? No. 2? Yes. Okay. 4 divided by 2 leaves me with 2, and I cannot divide anymore. Alright? So my pairs, I'm going to circle, because that means that a 2 is going to be on the outside of my square root that's being multiplied by that negative 1. Alright? And what's going to be underneath my radical? What's going to be underneath my square root, guys? My single 3 that's in that box. Okay? So again, underneath my square root, I'm going to have that single 3. Okay? So the numbers that's in front, I'm going to multiply them. So negative 1 times positive 2 is negative 2. Okay? I'm not multiplying anything underneath the square root of 3. So the square root of 3, I bring it down. And you see how both of them have a square root of 3, guys? That's the only way that this would work, alright? That's the only way I can subtract them, because both of them have a square root of 3. So again, I only subtract the numbers that's in front of them, the coefficients in front. Negative 2 minus 1 is negative 3, and I rewrite only one of the square root of 3's. Why do I only write 1, guys? Is because if I asked you what is negative 2x minus 1x, what would you tell me? Negative 3x. You wouldn't write the x 2 times. So that's the same concept being applied here. So let's do the next one, guys. All right. So again, guys, just like before, we're trying to add them. All right. Or add or subtract. In this case, only one of the terms can be simplified. Which one do you think cannot be simplified anymore? Yup, the one that I underlined in blue, alright? Because again, the square root of 10, if I prime factorize it, okay, I can divide it by 5, and I get a remainder of 2, but I have no pairs that I put together. So this term, I bring all the way down, okay, including the negative 8 that's in front, okay? So here, I see an 8 in front, but do I simplify the 8 as yet? No. That I'm going to bring a little bit down, about halfway down, okay, because I'm only simplifying what's underneath the square root. That's all we're doing, simplifying what's underneath the square root, okay? So I list my first 5 prime numbers, 2, 3, 5, 7, 11. So can I divide 160 by any of these? Only 5 for right now, right? 160 divided by 5 is 32, all right? Can I divide 32 by any of these? No, only the 2, and I get 16. 16 can be divided by 2, I'm left with 8. 8 divided by 2, I'm left with 4. 4 divided by 2, I'm left with 2. And I can't divide anymore. So now I'm going to circle my pairs. So I have one pair of 2's, all right? So that means I have 1 2 on the outside that's being multiplied by this 8, okay? But I have another pair of 2's. So that means that I have another 2 on the outside that's being multiplied by that 8, okay? So I have a single 5 and a single 2. So that means I have a single 5 and a single 2 underneath my square root. I should have written it with a little bit more space. So a single 5 and a single 2 underneath that square root. Okay? So now I'm going to go ahead and multiply. So 8 multiplied by 2 is 16. 16 multiplied by 2 is 32. Okay? So again, on the outside right here, when I multiply all of these, I would get 32. Positive 32. When I multiply what's underneath the radical, I know you can't see that clearly, but what's underneath the radical will be the 5 and the 2. So 5 times 2 is square root of 10. And you see how I have a square root of 10 to both of them? That's what we should have. If you did not get the same number underneath the square root, that means something is wrong, okay? So now I'm going to combine the numbers in front. So negative 8 plus 32 is positive 24. All right? And I rewrite only one of the square root 10s. All right? So again, guys, just like that.